A hospice pharmacist receives a prescription for 1% morphine sulfate oral solution. She has a 120 milliliter bottle of morphine sulfate labeled 20 milligrams per 5 milliliters and a 240 milliliter bottle of morphine sulfate labeled 100 milligrams per 5 milliliter. How much of the 100 milligram per 5 milliliter product must be mixed with the contents of the 20 milligram per 5 milliliter morphine sulfate bottle to prepare the desired percentage strength for the patient? So the desired percentage strength is this, 1% up here. So you're trying to force your bottle to contain 1% morphine. And you have these two bottles here. So you have one of the bottles that's 120 milliliters. And this concentration of this bottle is 20 milligrams per 5 milliliters. So I'm going to draw like a picture diagram of what this looks like. So you have the bottle with the amount of liquid in it. So this bottle is 120 milliliters. And the concentration in here is 20 milligrams per 5 milliliters. So that's this one bottle here, 120 milliliters bottle labeled 20 milligrams per 5 milliliter. So that's a concentration inside this bottle here. So next we have a different bottle, which is 240 milliliters and has a different concentration of 100 milligrams per 5 milliliter. So we have a different bottle here. This is a 240 milliliter bottle. And then this concentration in here is 100 milligrams per 5 milliliters. And then we're going to use this more concentrated solution and we're going to put it into this bottle here. And then what we want is to get 1% as our final solution. But we don't know how much of this to use to put in here, because that's what we're trying to find out. How much of this solution, this 100 milligram per 5 milliliter solution, how much of this putting it in this less concentrated solution to make 1%. So if you didn't understand my picture, I'm going to draw it word for word what we're trying to do. So we have that one bottle of 120 milliliters of this 20 milligrams per 5 milliliters plus an amount that we're trying to calculate of the 100 milligram per 5 milliliter, and that equals a 1% solution. Okay, so the next thing I'm going to do is convert both of these concentrations to percent strength so I can use alligation method. So the first one I'm going to do is this 20 milligram per 5 milliliter. So 20 milligram per 5 milliliter, I'm going to set that equal to some number of grams over 100 milliliters. I'm trying to force this to 100 milliliters because percent strength is equal to some number of grams over 100 milliliters. And whatever this number of grams is, that's the percent strength. So if this is like 1 gram over 100 milliliters, then the percent strength is 1. So that's why I'm trying to convert this concentration, which is over 5 milliliters right now. I'm trying to force it to 100 milliliters. So you can either cross multiply, or you could do another method, which I like to do. I see like 5 milliliters on the denominator. If I times this by 20, I'm going to get 100 milliliters. So that's why on the numerator, I'm going to do the same thing, just multiply it by 20. But make sure you realize that this concentration's in milligrams, and the percent strength is always in grams. So that's why sometimes I like to just convert this 20 milligrams right away to grams. So 20 milligrams is the same thing as 0.020 grams. Right, so that's the only thing I did, was just convert 20 milligrams to grams to make it easier to solve, because I want my number here in grams. So if I multiply this by 20, I'd have to multiply this numerator also by 20. So 0.02 times by 20, that equals 0.4 is going to be the numerator here. So our percent strength for this 20 milligram per 5 milliliter concentration is the same thing as 0.4%. So now I'm going to do the same thing to this other concentration, this 100 per 5 milliliter concentration. So 100 milligram per 5 milliliter is equal to some number over 100 milliliters. So I'm going to convert this 100 milligrams right away to grams. So 100 milligrams is the same thing as 0.1 grams. So you can solve this number here, this number. You can by cross multiplying, or you can do what I do. In order to get 5 milliliters to 100, multiply it by 20. So I'm going to do the same thing with the numerator. This 0.1 gram times it by 20. So then our percent strength here is 2% for this 100 milligram per 5 milliliter concentration. Right. So next I'm going to do alligation method. So I have my two different bottles here. So this 20 milligram per 5 milliliters is the same thing as 0.4%. And this 100 milligram per 5 milliliter is the same thing as 2% concentration, the percent strength. So I'm going to have my two stock solutions, 0.4%. Got my 2% here that I just calculated also. And I'm trying to make a 1% solution as my final bottle. Right. So when you do alligations, you just go across the line. So 0.4% minus 1, that equals 0.6 parts. And then for alligation for this bottom part, so 2%, follow the line diagonally, minus 1, that equals 1 part. So now I'm going to set up my ratios. So this top part here, this top half, represents 1 part of the 0.4%. And this bottom part here represents 0.6 parts for the 2%. I'm going to set up my ratio like this. So I'm going to put 120 milliliters over 1 part. So 1 part is the 0.4%, and I know I have to use 120 milliliters because the question says, like, you have this 120 milliliter bottle and you're going to be adding this other concentration, which is the 2%. I'm going to put that in this bottle here, this bottle of the 0.4%. That's why I have to use this 120 milliliters. That's considered 1 part for this 0.4%, which is the same thing as 20 milligrams per 5 milliliter. And then I'm going to set that equal to some number of milliliters. This N represents the amount of milliliters that needed to make the 1% using this 100 milligram per 5 milliliter, which is a 2%. That's why I'm going to put N here over 0.6 parts, because I just calculated that amount of 2% I needed is 0.6 parts, but I don't know the volume because I'm going to be adding this volume to this 0.4% bottle here. So you can just solve this by cross multiplying, and your variable N should be equal to 72 milliliters, and that's your final answer. 72 milliliters of this 2% is what you're going to be putting in here to make this entire bottle to be 1%. So if you understand that, you can stop the video now, but I'm going to show you how to do it algebraically, which is what I like to do. So when you do alligation here, so I have 1 part and 0.6 parts, I'm going to add these 2 parts together, so that equals 1.6 parts. 1 plus 0.6 is 1.6. And so I always put each of these over what I just calculated, the total. Because then when you multiply this by the total volume, then you'll know like how much of that, in this case, the top half, the 0.4%, how much milliliters to use. That's why I would multiply this by 120 milliliters plus N. That's because the final solution that I'm going to have is, because I have to use 120 milliliters plus the unknown amount that I'm trying to calculate of the 2% that I need. And then I set that equal to 120 milliliters because I must use 120 milliliters. And so when I solve for this algebraically, this part here, I mean, you get 1 divided by 1.6 is 0.625, and then times it by 120 plus N, is that equal to 120? Then I'm just going to multiply this out. 0.625 times 120, that equals 75, plus 0.625 times N equals 120. And then subtract 75 from both sides. And then divide both sides by 0.625. And you should get the same answer. So either way, you can do it. I mean, if you know how alligation works, you can solve it this way algebraically, but it's a little bit tougher. But if you're really good at math, you should do it both ways, and then you guarantee you have the right answer. So if you have any questions, please leave it in the comments.